langsung ini dibawakan khas kepada anda oleh Akademi Youtuber Malaysia. Tumpukan perhatian anda, siaran langsung akan bermula sebentar lagi. Link sijil akan diberikan di hujung siaran ini. Pastikan diisi dalam tempoh yang ditetapkan. Terima kasih.
Hi, Salam, Sejahtera, and good evening, everyone. Welcome to Pusat Tuisyen Akademi Youtuber with the joint venture of eDidik Malaysia and Club Tulu Malaysia. So, hi, Jimmy and Cikgu Hasnitah. So, welcome to my lesson today. Okay, I'm Mr. Peh. Currently, I'm teaching at College Tingkatan 6 Tun Fatimah Melaka. I'm the teacher on duty for this week. And for today's lesson, they will be expected completed within 1 hour. And I'm excited to tell you that today we are going to our last subtopic for Form 5 syllabus of academic year of 2024. So there will be 7.3. Okay, so 7.3 Einstein Photoelectric theory. Okay, so for information, as usual, for this week we also have already conducted one of the lessons, which is the Form 4 Physics, and presented by Cikgu Rosemawati. So for Form 4 syllabus, they still at chapter 5 with the subtopic number 1. So Asas Gelombang. If you miss out the class, you may visit the channel for Cikgu Rosemawati to get the lesson. Okay, so besides that, I would like to tell you that for the link schedule for class today, it will be given to you with the link just after the end of the lesson. And you have to fill out with any email you are available within 30 minutes. Okay, so without further ado, let us start our class today. Okay, so today we are going to our last subtopic for chapter 7, which is Einstein Photoelectric theory. And for this subtopic, there are about 6 learning standards you are going to learn. And I actually already simplified to 2 parts, where the learning standard 1 until learning standard 4 will be related to the Einstein photoelectric equation. So it's more on the calculation. Okay, and then the last 2 learning standards will be actually the application of theory. Okay, so let us start the lesson. Okay, so the learning standard 1 is to set the minimum work function needed by the matter to emit an electron using Einstein equation. Okay, so from learning standard, from subtopic 7.2, where you learn already with Cikgu Hasnitah. So you should know already the photoelectric effect, where the electron will be emitted from the metal surface when the photon energy with minimum threshold frequency strike to the metal surface. Okay, so the electron will be emitted. So now in this subtopic, we need to relate with this equation we know as an Einstein equation. Okay, then for the learning standard 2 is explain the threshold frequency and together with the work function. So what is the definition for these 2 physics terms? Okay, then for learning standard 3, you have to able to determine the work function of the matter with the equation. Okay, I will show you how we get this equation. W equal to H time frequency, threshold frequency. Then the learning standard 4 will be problem solving involving Einstein equation for photoelectric effect. So this is the equation where I show you at learning standard 1 just now. Okay, so here, firstly, let us discuss the Einstein photoelectric theory. Okay, so what is the theory? So Einstein actually applied the Max Planck idea for the energy quantum. Okay, so if you have followed my 7.1 subtopic, okay, so you should understand already what means by the quantum energy. Okay, so if you follow the classical theory, okay, so the energy is recognized by all mixed out together. Okay, but this theory is not able to apply in some of the observation. Okay, so the energy is actually separated and they are grouped like this image. Okay, so we know as a quantum energy. Okay, so he suggested that the energy is carried by light particles and known as photon. So this is the photon. Each quantum of light is discrete packet of energy. So discrete, they will be separated just like this figure. Okay, so there are many energy packet in beam of light. Okay, just like this GIF, where showing by the purple color light beam. Okay, then they shine on the metal surface. So this is a metal surface. So you can see there is a blue color dot showing the photoelectron emitted from the metal surface. Okay, so when a photon arrives at metal surface, the photon energy will be fully absorbed by an electron in metal. Okay, so to ensure that the electron emitted from the metal surface, so the electron in the metal must able to gain enough energy to overcome the bond between the electron actually. Okay, so number 6, the energy of each photon E is directly proportional to the frequency of light with unit with symbol F, and can be determined by the following equation. And this equation actually you learned already at learning center 1. Okay, so where E equal to HF. So the E will be the photon energy. Okay, so here H will be the Planck constant. Then H will be the frequency of the light or photon here. Okay, so according to Einstein, the electrons are only released from the metal surface if the photon frequency or photon energy exceeds the threshold frequency or the metal work function. Okay, so here, if the energy provided is less than the work function, so the electron is actually not able to overcome the attraction and emitted from the metal surface. Okay, so that the work function can actually define as the minimum energy needed for photoelectron to be emitted from the metal surface. Okay, so the blue color dot will be the photoelectron where stay inside the metal. Okay, so when the energy absorbed by the electron, when the photon beam with the minimum threshold frequency strike to the metal surface, so the energy gain will be able to overcome the attraction and emitted as a free photoelectron. Okay, so the threshold frequency will be the minimum. Okay, so the threshold frequency will be the minimum frequency required to produce a photoelectric effect on the metal. Okay, so if you learn through the subtopic of 7.2, you should know already the photoelectric effect, there will be the electron emitted from the metal surface when they gain enough energy from photon energy or the light energy provided. Okay, so the next here, electron will be emitted if the photon energy E of the ray exceeds the energy of metal bond. Okay, of metal bond of the metal. Okay, so here will be known as a work function. So that means that if the photon energy provided is just enough to overcome the metal bond, so they are actually only gain the work function and still not able to move freely with speed from the metal surface. So they will be just able to release themselves and stare at the metal surface. Okay, so same type of metal have the same work function. Okay, so this actually you learn at the subtopic 7.2 already. So you can see here, if the metal is sodium, okay, so the threshold frequency will be equivalent to 4.40 times 10 power 14, and its threshold wavelength will be 682 nanometer. Okay, so the different type of metal, they will have different threshold frequency. Okay, that means they will have the same amount of work function, as the work function formula will be W equal to F times threshold frequency. Okay, so that means they will have specific work function for specific type of metal. Okay, then the next here, you can see for case number 1. Okay, so the photon energy provided, E, is less than the work function of metal. So there will be no any electron will be emitted. Okay, you can see the photon beam is below threshold frequency. So that means the energy gain will be smaller than the work function of the metal. So the energy gain will be not able to overcome the attraction. Okay, overcome the attraction in the metal bond. Okay, so then the next here will be when E equal to W, that means the photon energy equal to work function. Okay, so the electron will be gain enough energy, okay, so to overcome the metal bond and emitted with 0 kinetic energy. Where will be at the metal surface? They will just start to emitted from metal. Okay, so when the E or the photon energy is greater than the work function, okay, so the electron will be emitted and move freely with the maximum kinetic energy. Okay, so they will be moving at certain speed where label with V max here. Okay, so welcome for Iron Shark, okay, to my lesson. Okay, and also Jimmy together with Cikgu Hasnitah also. Okay, so let's continue our next slide. Okay, so here will be the Einstein equation. Okay, so the Einstein equation will be follow this formula. Okay, so for the electron on the metal surface, just now we had 3 different cases. The first, when the E less than the work function, so the electron will be still stay inside the metal, cannot be emitted. Then the second case where the E equal to W, or photon energy equal to work function. Okay, so the electron will be emitted with zero kinetic energy. But when the E provided, or the energy, photon energy provided, is greater than the work function of the metal, so it will be moving with maximum kinetic energy. Okay, so the formula will be like this. Photon energy provided will be used to overcome the metal bond in the metal so that the electron can be released. Okay, so this is a minimum energy required to release a photon electron, and this will be known as work function with symbol W. Okay, and then the energy absorbed will be able to let the photon electron moving with maximum kinetic energy. Okay, so we can simplify this Einstein equation with E equal to W plus Kmax. So the Kmax will be the unit for the maximum kinetic energy of photon electron. Then W will be work function and E will be photon energy. Okay, so as E equal to HF, where you learn already the formula in the subtopic 7.1. Okay, so it will be substitute E to HF. And then the kinetic energy will be with formula 1 over 2 mv squared. Okay, so here, since the kinetic is maximum, so the photon electron will be moving with the maximum speed. So they will be form this equation. Okay, so where half mv square max will be actually equal to Kmax. Okay, so that means the Kmax, so maximum kinetic energy of photon electron, will be equal to HF minus W. Okay, so where the F will be the frequency of the light strike to the metal surface. And then the W will be the work function for the certain metal. Okay, so this equation will be accordance with the principle of conservation of energy. So where the energy provided by photon energy will be used as work function for the electron to overcome the metal bond, and the extra energy gained from photon energy will be the maximum kinetic energy gained by the photoelectron. Okay, so here the equation can be derived or expressed in graph Kmax against the F. Will be this graph. You can see the y-axis will be Kmax. Will be Kmax. Sorry. And then the F will be at axis X. Okay, so here this will be the Einstein photoelectron equation where we explained just now. Okay, so we can rearrange the formula, become Kmax equal to HF. This will be HF minus W. Then we express in linear equation where the Y will be Kmax, X will be the F. So the gradients M of the graph will be the value of H, which is a Planck constant with the value of 6.63 times 10 power negative 34. Okay, then the C or the Y-intercept will be represented as the work function of metal. Okay. Okay, so this will be the relationship of the Kmax versus F to get the first gradients. So the slope will be equal to H, which is the Planck constant. Okay, then the next you can get will be the W. So where it is actually showing the value for the work function of the certain metal. Okay, then the F naught, where is actually the X-intercept is showing the threshold frequency for the certain metal. Okay, so this will be actually the value you actually can get through the graph Kmax against the F, where actually derived from the Einstein photoelectric equation. Okay, so from the graph you can see there is a straight line with the positive gradients. Okay, so that means that the higher the photon energy, the higher the photon frequency, so the higher the kinetic energy released by the electron. Okay, so here, this will be the relationship between the work function W with the threshold frequency, F naught. Okay, so when the threshold frequency F naught is released without any kinetic energy, where Kmax equal to 0. Okay, so this equation will be showing that the Kmax is 0 when the F is equal to F naught. Okay, so from here, we can get the relationship between the work function and the threshold frequency is actually Dari proportional. So that means that the threshold frequency for certain metal, if I say very high, so the work function needed is also very high. Okay, so here, same type of metal above has the same work function. This one just now I mentioned already. Okay, so we can compare the graph KMax with against frequency for different type of metal. Okay, so from here, you can see for metal A, it has a frequency, threshold frequency of F naught A. So here will be showing the lowest value. So that we can conclude that the work function for metal A will be the lowest compared to B and C. Okay, then secondly, you can see that all of three metal showing the same gradients value. Okay, so this is true also because the H value is always constant. Okay, where equivalent to 6.63 times 10 power negative 34. Okay, so here as mentioned, W equal to HF naught. Okay, so as C has the highest threshold frequency, so the work function for metal C will be the highest compared to B and A. Okay, so this is what actually the graph try to tell you. Okay, so let's go through together the question number 1. So where is related to the learning standard 1 to 4. Okay, we go through just now. Okay, you may show answer in the chat room so that I know that you are learning together with me here. Okay, so the first question will be like this. So we have a blue light with frequency 6.67 times 10 power 14 hertz to shown on the green Lydian metal surface. Okay, so what is the maximum kinetic energy of the photon electron emitted? Okay, so here firstly, you can give the symbol for the value so that you can select the correct equation for your calculation. Okay, so here the first it will be with unit of hertz. This will be the frequency for the blue light. So given F will be equal to 6.67 times 10 power 14 hertz. Okay, then another value is given in the question. There will be work function in unit of EV. Okay, so the EV also showing the unit for energy, which is work function. Then the unit SI for energy is actually the joule. Okay, so you can see here the answer in the option is given is joule. So you have to change your EV value to joule. So where 1 EV will be equivalent to 1.60 times 10 power negative 19 joule. Okay, so here the question asks about the KMax. Okay, so the KMax will be with unit, should be simple KMax or 1/2 V square max. Okay, so from the formula list, you have to choose the correct formula for the calculation. So with the unit, with the symbol we stated, so there will be more easily for us to select the correct formula. So the formula will be number 7. Okay, so H equal to W plus 1/2 MV square max. Okay, so here, since the question asks about the KMax, so we just need to substitute the value of H, which is given as 6.63 times 10 power negative 34. Okay, then F, given already, and then minus W. Okay, so W will be in the unit of EV. Okay, so 1 EV, as per mentioned, just now it will be equivalent to 1.6 times 10 power negative 19. Okay, so here we just substitute our value where H with the value given. F is also given by the question already. Here we need to change our EV to Joule by multiply with 1.6 times 10 power negative 19. Okay, so thank you, Cikgu Rosemawati, for joining my lesson. Okay, so you just need to, using calculator, press, you can get your value. Will be 4.422 times 10 power negative 20 Joule. So it will be equivalent to answer C. Okay, so this is actually the trial question, Johor 2024, this year, question number 40. Yeah? Okay, so the next question, question number 2. Again, this will be also the trial question 2024 for Kelantan State. Okay, so the question will be like this. A monochromatic light with a photon energy 2.00 eV is shown onto the clean cesium metal surface. So calculate the wavelength of the monochromatic light. Okay, so again, just give the symbol for the value given. So here E is actually the photon energy with 2.00 eV. And then the question given us HC with the value of 1.243 times 10 power 3 eV nanometer. Okay, so the question asks us to calculate the wavelength. Okay, so again, we need to select the suitable equation. Okay, so here the equation will be number 5. E equal to HC over lambda. Okay, so we rearrange the position E with lambda, then we will get HC over E. Okay, so here we just need to substitute the HC value given and then the E value given. So we will get our value of lambda in nanometer. So actually the question is quite straightforward. This will be 621.5 nanometer. So it is very clear that the answer is D. Okay, then the next question here is also the trial question 2024 from Kelantan State. Okay, so which of the following statement is a characteristic of photoelectric effect? Okay, so this will be the theory question. So the first, intensity of light affects the energy of photon electron. Okay, so sometimes we are not sure that the statement is correct or not. Actually, you can using the formula list to get the answer. Okay, so here again, the energy of photon electron, you need to give the unit. You need to identify the correct unit, correct symbol E. Okay, so from the formula, is it the E of photon energy is dependence on intensity of light? Okay, so you can see here, the E is actually depends on the wavelength for equation number 5. Okay, so another E you actually can get from the first equation. So that means the E value is affected by frequency and the wavelength, but it's not depends on the intensity. So this one is wrong already. The option A is wrong. Okay, then the next here will be the greater the photon, the frequency of photon, the greater the maximum kinetic energy. So is it this statement is correct? So we have to choose the appropriate formula to relate the statement here. So the equation used supposed to be this. Okay, so we will arrange, you will get the value of Kmax is actually direct proportional to the value of F, frequency of photon. Okay, so that means that the statement for option B is actually correct already. Okay, this is supposed to be B. Okay, so let us look at the C. So why the statement is wrong? Okay, so the emission of electron from the surface of matter is occur when cathode is heated. Okay, so this is actually the thermionic emission where you learn already at chapter 5. Okay, so it's not related to photoelectric effect is affected. The electron is emitted from the metal surface due to the photon energy, where the energy provided is greater than the work function. Okay. Then the D. So here work function known as the minimum energy is not frequency required to emit the electron. If I say the minimum frequency required to emit the electron, this is the threshold frequency of the metal. Okay, so here the answer very clear, that will be B. Okay, then the next question here will be the question number 4. Again, this is a try question 2024 from State of Negeri Sembilan. Okay, so this is also one of the theory question related to learning standard 1 to 4, just how we learn together. Okay, so diagram 25 shows a process that occurs when light is shone on the metal surface. The photon is here. Okay, so this will be the metal surface. Okay, and then when the photon energy provided, E, is greater than the work function of the lithium metal, so the photon electron will be emitted. Okay, so this is what we learned just now. Okay, so which of the following is true based on the process that occurs as in the diagram? Okay, so which following is true based on the process that occurs as in the diagram? Okay, for the first, photoelectrons are emitted if the value of light energy, light frequency U is less than the threshold frequency. This one definitely wrong already, right? Because the frequency provided by the photon must be greater than the threshold frequency of metal. Okay, so here this is wrong already, because here suppose will be more than. Okay, so option A is wrong already. So look at the B. Okay, so then if I say you have your answer, you can share at the chat room. Okay, so then we can discuss together here. Okay, so B, the work function for the metal is maximum photon energy required to produce a photoelectric effect. Again, this suppose will be minimum, right? Because we discussed already the definition. So here is minimum. Okay, so option B is also wrong already. Okay, we look at C. So maximum kinetic energy of photoelectron depends on the frequency of photon. Okay, so again, you can relate this with the formula, where you can actually get from the formula list in the question. Okay, so here you can see the frequency is related to the Kmax, will be this. Okay, so here the option C seems like correct already. Okay, then the D, the photon energy value is greater than the threshold. Is greater than the threshold frequency. Okay, so here suppose we need to discuss equal. Okay, or actually the photon energy value here we need to, if let's say we want to allowing the electron to emitted from metal surface, so this suppose will be work function. Okay, so must be greater than work function of metal, so that the photoelectric effect will be occur. Okay, so here answer very clear, there will be C. Okay, then the next question, again, this is a trial question 2024 from the state of Pahang. Okay, so again, this is a theory question very related to subtopic today. Okay, so which of the following is true regarding the Einstein's photoelectric theory? Okay, so again, here the first statement, the higher the value of threshold frequency, the lower the value of work function. Again, this relationship we can get through the formula list, where we select the equation number 8. Okay, so W equal to H times threshold frequency. So you can see here, actually, W and the F naught here is directly proportional. So the higher the value of threshold frequency, the work function will be higher. So here is strong already for this statement. Okay, so we look at B. Okay, so the at the threshold frequency, F naught, electrons are emitted with low kinetic energy. Okay, so here, again, this will be wrong. Okay, right? So when the photon energy provide with threshold frequency, okay, so here, that means the kinetic energy will be 0. Okay, so the photon electron will be just stay at the surface of matter without any speed. Okay, so then the Einstein'S photoelectric equation for the photoelectric effect is accordance with the principle of conservation of energy. This is correct, right? So here is energy provided by the photon. Then this will be the energy used to overcome the metal bond, as I mentioned just now. And then this will be the extra energy gained by photon electron and moving with the maximum kinetic energy. Okay, so answer supposed to be C. Okay, so we look at the option D, where is the part incorrect. Okay, so the more the intensity of light increases, the more the kinetic energy of the emitted photon electron increases. So again, here you have to look at the equation 7. So you can see the Kmax here is not dependent to the light intensity. It's dependent on the frequency of light provided or the wavelength. Okay, so answer is very clear that there will be C. Okay. Okay, so the Kmax is not depends on the intensity, but frequency and wavelength. Okay, so here, this will be the paper 2 question. Okay, so the conception question related to subtopic today, example 3. And again, this will be the trial question for this year. Okay, from still Salam. Okay, so the question will be like this. Diagram shows a graph of maximum kinetic energy with unit of Kmax. So against the frequency where F naught A, this will be the threshold frequency for metal A. And then the F naught B will be the threshold frequency for metal B. Okay, so work function for metal A given as 2.14 eV. And then for the metal B will be 2.5 eV respectively. Okay, so the graph just now we also explained already. Okay, so this is a related question. Metal A and metal B is irradiated with the light with frequency X. Okay, so tick the box for correct answer. So work function. Okay, so this is asked about the definition for work function. Okay, required for photon electron to be emitted from the metal surface. So again here, it will be energy, right? Okay, so answer very clear that work function, we discuss about the minimum energy needed. Okay, for photon electron to emitted from the metal surface. Okay, so the answer, it will be minimum energy. Okay, so then the B, okay, so this will be the conception question. So here we'll do comparison between the metal A and B. Okay, so the first question will be based on the diagram, this diagram. Okay, so the threshold frequency of metal A and metal B. So we have two metal. So you have to compare their threshold frequency. So you can see very clear that they will be here. So the value for F naught A definitely will be smaller compared to F naught B. So that means that the metal A will be smaller than B. Okay, this will be the answer. You can use a symbol to write your answer. Okay, then the B, B2, work function. Okay, work function of metal A and metal B. Just now I also showed already. Okay, so here we're using formula 8, where we can get the relationship between the work function with the threshold frequency. So they are inverse, they are directly proportional. So that means that when the threshold frequency for metal B is higher, definitely the work function is higher compared to B. So answer will be A is smaller than B. Okay, then the next here, Okay, so here, maximum kinetic energy of the photoelectron emitted from metal A and metal B, shown by the light with frequency X. Okay, so here we want to compare which has a higher Kmax. Again, we're using formula to discuss. It will be equation 7. Okay, so we will arrange, we can get that the Kmax will be equal to HF minus W, right? So the W can change to H F naught. This will be E, this will be W. Okay, so further simplified, the Kmax will be equal to H with F minus F naught. Cool. So here, if the metal B has a higher threshold frequency, so the overall value of K will be decreases, right? With this equation, these two values will be fixed. Okay. So that means that the Kmax for metal A will be greater than metal B. Okay, so this is how you can use the formula to relate the relationship in this question. Okay, then the next here, based on the answer in B, relate the threshold frequency F naught with the work function. Okay, so here just now we also explained already. These two will be directly proportional. Okay, so the higher the threshold frequency, the higher the work function of the metal. So that means that the electron will be more difficult to emit, or more energy or photon energy is needed to overcome the metal bond so that the electron can be emitted. Okay, then the next here will be the relationship between the threshold frequency with the maximum kinetic energy of photon electron emitted. Okay, so here just now we also explained already. Okay, so here when F not increase, Kmax will be decreased now. So the higher the threshold frequency, the lower the maximum kinetic energy of the photon electron emitted. So this will be the answer. Okay, so now we go for our calculation question before we go for learning standard 4 and 5. Okay, so here, given that the frequency of the light, F, with this value, okay, so calculate the maximum kinetic energy. So here will be Kmax, or 1/2 mv square max. Okay, so you need to find out this value. Okay, then the question gives us the H, and 1 eV equal to 1.60 times 10 power negative 19. And then the question requires us to get the answer not in joule, but in EV. Okay, so from the question just now, we go through already. Okay, so we can get another value. Okay, so here ask about the metal A. Okay, so the metal A have the work function, which is equivalent to 2.14 EV. Okay, so the formula we'll use will be this. You can get through the formula sheet. Okay, so here, again, just now I highlight already, the answer for the Kmax must be in EV. Okay, so here, there will be HF. So overall of this, we'll get energy in unit of joule. So joule convert to EV. You have to divide 1.60 times 10 power negative 19. Okay, then you can get your value in EV for here. Then you minus the W. Okay, so the work function for metal A. Then you can get your answer as 0.9678 EV. Okay, so minimum you have to give 2 decimal places with current unit. You can give up to 3 and above. Okay, so this will be the discussion for learning standard 1 until 4. Okay, so now we can take 5 before we continue our learning standard 5 and 6. Okay, so we'll continue after break. Okay, so welcome back, everyone. Okay, so now we continue our learning standard 5. Okay, so this will be, you need to explain the production of the photoelectric current in a photocell circuit. Okay, so photocell circuit will be this. This is a simplified circuit in 2D. Okay, so here, the first, okay, so the cathode, okay, we label C. Okay, is coated with metal. Okay, coated with metal. Okay, so you can see here, this is a cathode, and there is a metal coated on the surface. So can be one of the example. Cesium is cesium is connected to the negative terminal. You can see here is connected with terminal negative of the battery. From here, connect to negative. Okay, and then the anode is connected to the positive terminal of the battery. Okay, so this is the connection. Okay, and then cesium was chosen as the cathode due to its low work function. Okay, so just now we also explained already. Okay, so with the lower work function metal, so the energy needed for photoelectron emitted from the metal surface will be lower, will be more easier actually. Okay, so the lower the work function, there will be more electron emitted when the light ray is radiated on the cesium surface. Okay, so here, if the frequency of the light exceeds the threshold frequency of cesium, so that means the F from the light is greater than the threshold frequency of the cesium. Okay, so the electron will be released from the cathode surface. Actually, you can also explain by using the photon energy provided is greater than the work function of matter. Actually, this both also able to explain this situation. Okay, then number 5, the released electron are attracted to the anode. So you can see here, the electron is charged negative. It will be attracted to the positive terminal in front. Okay, so the released electron are attracted to the anode. Eventually, the circuit is completed. So when there is a flow of electron, okay, so the current will be flow and able to detected by the microammeter, so that the microammeter will be deflected actually. Okay, then the number 6, this detected current is called photoelectric current. Okay, then now we go to our last learning standard for this subtopic. Okay, learning standard 6. Okay, we need to describe the application of photoelectric effect. Okay, so here there will be the flow electron and produce a current. Okay, so the first will be applied in the light detector of automatic street lamp. So this will be the example. Okay, you can see here, there is a solar panel. Okay, so LED lamp along the route, which are powered by solar cell. So this is a solar cell, energy efficient and environmentally friendly. Okay, so in daylight, okay, daytime, the photoelectric effect for solar cell enable electrical energy to be stored in battery. Okay, so that means the solar cell will be just like the structure circuit we explained just now. Okay, so they will be have the metal surface where have a low work function. Okay, so when the sunlight strike to the metal surface, okay, so the electron will be emitted and the energy will be produced and stored at the battery. Okay, or we can know as also the power bank. Okay, so at night the LED light will light up with the power from the battery. So that means the electrical energy we store in the battery or the power bank here will be used at night. Okay, so the light sensor is dependent on the light intensity. We will be look at this GIF now. So when there is a person nearby, the light emitted are higher rate and vice versa. Okay, so the next application will be at the light detector of automatic door. Okay, so light detector at the automatic door use infrared beam and photocell as switches. Okay, will be this figure also. Okay, so when light path is disturbed, photoelectric current in the photocell circuit will be disconnected. Okay, so when disconnected, there will be no electron flow and no current will be flow through also. So the door will be remain open. Okay, so this is the application number 2. Okay, then this will be the last application for our discussion today. Actually, you can get more application in your textbook also. Okay, so solar cell in the satellite. Again, when we see the solar cell, there will be have a metal surface where will be readily receive the light energy. And the electron emitted will be cause the photoelectric effect occur. And the photoelectron current will be produced. Okay, so satellite power with solar cell. There are orbits around the Earth and depends on the electrical energy generated from the solar panel. Okay, so the electrical energy actually come from the solar panel. Okay, so solar cell operate using photoelectric effect. So when light or photon from the sun reach the surface of semiconductor, okay, so the electron are released and produce a current. Okay, so this is how the satellite operate. Okay, so here we go to our last question today. So this will be the trial 2024 from Negeri Sembilan State. So this is question paper 2, section B. Okay, it's a decision making question, which is total 20 marks and related to subtopic today. Okay, so diagram 10.1 shows beam being detected to photocell. Will be this time. So what is the means by the work function? Again, this is the definition. Okay, so just now we also learned already. It will be minimum energy needed for photoelectron to be emitted from the metal surface. It's very straightforward. Okay, then the next question here. Okay, so based on the diagram 10.1, describe how a beam or light shown to the photocell can produce electric current. Okay, this one just now we also explained already. Okay, so the photon energy provided here must be greater than the work function of matter. Okay, so that the electron will be able to emit with Kmax Okay, so the first photon of light shone onto the metal will be the first answer. Okay, then second, photon energy must be accessed the work function. Okay, just now I explained already. You can using photon energy greater than the work function of metal, or you can using frequency of light emitted to metal surface must be greater than the threshold frequency of metal. These two can be used to explain the situation, okay, where the energy needed. Okay, so when the photon energy exists the work function, that means the photon electron will be able to emit from surface of metal and with the maximum kinetic energy. So the photoelectric effect will be occur. Okay, then photoelectrons are emitted from the metal surface. This may cause the flow of electron and the electric current will be produced. Okay, so here this is a decision making question. Okay, so diagram 10.2 shows the parts of satellite. Okay, so here if you look at the diagram 10.2, it consists of the this will be here and the panel. Okay, so table 10 show the JKLM specification for 4 satellite. Okay, you can see here it will be comparison with satellite JKLM, and here they will be a different size of panel. Okay, so here J and K will be a smaller panel size, while L and M will be bigger. Okay, then the second characteristic we want to study here will be related to the satellite body building material. Is titanium or fiberglass? Then next will be the type of satellite. This is related to chapter 3 Form 4 syllabus is whether geostationary or non-geostationary. Then the last here will be the diameter of the plate. Okay, will be this here. Okay, so you are required to study the specification for 4 satellite and decide which satellite is most suitable used to make international video call clearer. So that means here is actually used to telecommunication purpose. Okay, so the first, here the size of panel will be here. Should be smaller or bigger. You cannot give the value for this answer. Okay, so here, just like I mentioned already, so J and K have the smaller size of panel, while L and M will be bigger. So definitely we need to have bigger panel so that the panel can receiving more sunlight, so more electrical energy will be produced now. So here, L and M should be the option. Okay, then answer larger should be choose reason can receive more light energy. Okay, then the next here will be the satellite body material. Okay, so since we choose L and M already, so we don't need to see again option for J and K. We focus on L and M only. So here we should choose titanium. Titanium is a stronger material compared to fiberglass, and it is also lighter. Okay, so we should choose titanium because it is lighter and also stronger compared to fiberglass. You can see here, we are very clear that the option should be go to satellite M. Okay, so this is how we cancel the not possible value, the answer, so they can get more, you will be more easily go to the where selection at the final. Okay, then here, the satellite here, there will be geostationary, right? See, we have the last option here. And the geostationary satellite will be used for telecommunication. Okay, so where the position is always fixed at certain position of country. Okay, so here, so here suppose to be geostationary, should be chosen. Okay, so reason here is option always above the same geographical location or same as the direction of Earth rotation. Okay, so here for non-geostationary satellite, normally will be used for Earth imaging, GPS for navigation purpose, and also for weather forecast. Okay, then the last here will be the diameter of the plate. So will be here, will be here. We should choose bigger so that we can receiving or be providing the wave more easily. Okay, so here will be larger. Okay, so that the wave can be received or reflected more. Okay, so we are very clear that the option will be M. So M, because it has a larger panel size, titanium as a building material, and is a geostationary satellite and has a large diameter of this. You can just copy your 4 character as your last answer here. Okay, then the D will be the last question for today's discussion. Okay, so diagram 10.3 shows the photo cell map of the lithium material with the value of threshold frequency. Okay, so threshold frequency given as 5.6 times 10 power 14 Hertz. Okay, so the metal is then illuminated with the violet light with a wavelength 4 times 10 power negative 7 M. Okay, so photo energy. So you need to calculate the photo energy of violet light. Again, referring to your formula list. Okay, so which formula you are going to use? Seen here, lambda given as 4 times 10 power negative 7 meter. Okay, so you have to choose formula number 5. Okay, you just substitute your H with 6.63 times 10 power negative 34. Then C will be the speed of the light, which is 3 times 10 power 8. And then the wavelength of the light given already. You just substitute, then you can get your value equivalent to 4.9725 times 10 power negative 19 joule. Again, your value given must be minimum 2 decimal places with correct unit. Okay, so I advise 3 and above here. Okay, then the next question asks about the work function for lithium. Again, work function, you just need to select the formula. Okay, so here the question given us F note for the lithium already. Okay, so suppose will be formula number 8. Okay, so you just substitute H with the given value 6.63 times 10 power negative 34 with the threshold frequency given in the question over here. Then you can get 3.7128 times 10 power negative 19 joule. Okay, then the last question here, this will be maximum kinetic energy of photoelectron emitted. So this will be Kmax. So it will be equation number 7. Okay, so number 7 here, actually the question asks about the Kmax. And W we get already at the answer in question number 2. And then the HF is actually the E, where you get already in question number 1. So the Kmax here will be using answer 1 minus answer number 2. Okay, answer 1 minus answer 2. Okay, so you will get 1.2597 times 10 power negative 19 joule. Okay, I think this should be not very hard for you to use the Kmax formula here by reference of the formula in formula list. Okay, so that's all for my sharing for subtopic 7.3 today. Okay, so before I end the lesson, I would like to share to you the link e-schedule for today's lesson. Okay, so I would like to share to the chat room. Okay, so the link already shared to chat room. Okay, you may actually fill up with any available email. Okay, and then please fill up within 30 minutes after the live for today end. Okay, so thank you everyone for learning together with me until here. Okay, so please share my lesson today to your friends so that more of your friends can gain more benefits from my lesson today. Okay, again, this will be the last subtopic, as I mentioned just now, last subtopic for Form 5 syllabus of Physics SPM, academic year of 2024. Okay, so since you still have another 1 month for your paper 3, which will be held on, I think it's 9th of December, right? And then the paper 2 and paper 3 will be 15th of January. Okay, so the next session, we still will be conduct together with you all, okay, so that you all can do revision with us. Okay, so we'll be preparing the revision series to all of you so that you all can have a revision with us. Okay, so remember to follow us again. So for the class Form 4 Physics will be on every Friday, 9:30 p.m. Okay, again for the Form 5 class will be every Sunday, 8:45 p.m. Okay, so we'll still continue with the revision series to you all. Okay, so please stay together with us before your exam. Okay, I think that's all for my sharing today. Okay, so thank you for continuing with me until now. Okay, so bye-bye. See you next week.